Okay, guys, so this week we will be going over transmitting ability and genetic predictions, which is another way of just saying we're going over EPDs and kind of how they work. So, this lab is going to be two labs worth, meaning that we'll have a lab this week over EPDs as well as a lab next week over EPDs. So, this is just kind of the intro, get your feet in the ground, and for those that don't know anything about EPDs. So, to start off, we have some terminology, and this packet that I'm looking at right now is on eCampus. But we have some terminology that you need to know. Quantitatively inherited characters is one of them, and differences among animal for quantitatively inherited characters are due to differences at genotype at many loci, as well as environmental influences. Uh, then we can move on to transmitting ability, and transmitting ability is a measure for the genotype for a quantitatively inherited character. Basically, the average amount that a very large number of the animal's progeny would differ from a progeny of an animal whose transmitting ability is zero. So it also says the EPDs are estimates of transmitting ability, and an easy way to think about it is transmitting ability is measuring a trait at which a large number of offspring, the average amount of that for the trait for a large number of an animal's offspring is going to be different from an animal whose transmitting ability is zero. So if I had an EPD of an animal whose birth weight is 2.3 pounds, positive 2.3, and all that is saying is that animal differs, or the average is going to be 2.3 pounds greater than an animal whose EPD is zero, which makes sense. So then moving on to EPDs, I mentioned that a lot. Basically, all an EPD is the expected progeny difference. So how much an animal is going to differ from another animal, or how much the progeny is going to differ. So an animal's EPD for a particular character is the average amount that its progeny are expected to differ due to an animal or differ from an animal whose EPD is zero for that character. So that's direct effects. Maternal effects, it's a little different, but it's still the same thing. How much an animal's EPD for a specific trait is expected to differ from a progeny whose EPD is zero. But this is going to be due to maternal effects. So we're looking at the average amount that the daughter's progeny, not just the progeny, but the daughter's progeny. So direct effects and maternal effects are a little different. But direct effects are just the animal's progeny. Maternal effects are going to be the daughter's progeny. So that animal's daughter's progeny. So if I was looking at a bull, I'd be looking at the bull's daughter's progeny, and that would be the maternal effects on any trait that I was looking at. So moving on, we'll look at possible change values. So possible change values are also abbreviated PCVs, and they are sorry guys, they're standard errors of a trait. So standard error, it's a measure of precision of an animal's EPD that defines an interval where there's a 68% probability that this animal's true transmitting ability is between 1 PCV below the EPD and 1 PCV above the EPD. So for those of you that kind of remember what was going on during statistics, this is all we're looking at. We're looking at how the EPD what is the probability being 68% that an animal's transmitting ability lies between one standard error above and below the mean. So that's just kind of some terminology, some definitions that y'all need to know. We're gonna move on and do a couple of examples today. If y'all still are a little, if y'all still don't quite understand it, we'll go through some examples. But so when we're calculating EPDs, y'all won't have to calculate them, but this is just some information for y'all that you need to know how it was calculated. So when calculating the EPDs, we look at the performance of the parents as well as the performance of that animal's half-siblings, as well as their own performance. Then we also looked at the performance of the progeny of that animal as well as its grand progeny. So that's just kind of what we use to calculate the EPDs. And now we're going to kind of go through some examples. We're going to start off fairly simple and then kind of move toward a little bit more, or a little harder questions, I should say. So right here, when we look at the difference between bull A and bull B, we have two EPDs, birth weight and weaning weight. So to find the difference between bull A and bull B, it's as simple as subtracting the larger one from the smaller one. In this case, bull B's birth weight EPD is +4, meaning that it is 4. You expect that bull's average to be 4 pounds heavier than an animal whose EPD is 0, which that would make sense. But when comparing it to another bull, bull A, at -3 pounds, all we do is to take the difference. We expect bull B to be 7 pounds, or bull B's offspring to be 7 pounds heavier at time of birth than bull A's offspring. And to do that, we just simply do 4 minus the -3, which gives us 7. Weaning weight's the same thing. You take your larger one, 43 pounds for bull B, subtract it from 20 pounds for bull A, and that's going to give you 23 pounds. So you expect bull B's offspring to be 23 pounds heavier at weaning than bull A's offspring. But in this case, bull B's offspring is going to be 43 pounds heavier than an animal whose transmitting ability is 0 at weaning, and bull A's offspring is going to be 20 pounds heavier than at weaning than an animal whose transmitting ability for weaning weight is 0. So that's just kind of showing the same thing. And this is all depending on if these bulls were bred to the same cow. So down here at the bottom, if these two bulls were bred to similar cows or the same cow under the same management, these would be the differences that we would expect the offspring to have. However, it's not always going to be 100% true. So we have to make sure we keep that in mind, that EPD does stand for expected progeny difference. We never know what the actual progeny difference is going to be, but we can give a very well-educated guess, and that's what we're doing. So when looking at these two bulls, you can compare let's talk about their weaning weight. So bull A is right here at +20, and bull B is at +43. So as you can see, there's a 23-pound difference. That's right, the 20 and 43. There's a 23-pound difference between the two. However, because these are expected, bull A's weaning weight could be right here, while bull B's weaning weight could be right here. Now, the likelihood that that's going to happen, or the probability that is going to happen, is going to be slimmer than if it were 20 and 43 for bull A and bull B respectively. But it's a possibility that could happen. So this is what we have to keep in mind when we're looking at EPDs. So there are 3 EPDs that are a little confusing. Y'all don't need to know all the EPDs on page 3 through 5, but if you look, these are all the EPDs for Hereford, and you can read through and kind of understand what's being measured, how they measure it, and understand why they measure it. But yeah, these are pages 3 through 5 show a bunch of different EPDs that are measured in the Hereford Association. But we ask that you know the main ones, and we'll go through the main ones here in a second. But these 3 right here on page 2 are extremely important for you to know.